Let's take a look at this example. Consider the quadratic function f of x equals negative x squared minus 3x plus 4, and we want to determine the following as either integer, fraction, or a decimal. So let's start with the x-intercepts. Now, quick recap. In order to find the x-intercept, we need to set the y value, which is same thing as the f of x value, equal to 0. And then once we do that, we need to solve for x because we're looking for the x-intercept. So in this function here, I'm going to set the entire left-hand side, or the f of x, equal to 0. So we're gonna get 0 equals to negative x squared minus 3x plus 4. Now recall that it's always helpful to have the leading coefficient. In this case, it's the coefficient of the x squared be a positive value. So the first thing I'm going to do is I'm going to divide everything by negative 1. And we can only do this once we set this equation equal to 0, or that expression equal to 0. So once I divide everything by negative 1, here's what happens. I get 0 on the left side. I get a negative divided by negative is a positive x squared. Negative divided by negative is a positive 3x. Positive divided by negative that's a negative 4. Now there are a couple of ways of solving this. We can either use a quadratic formula, or we can use factoring. And of course, factoring is easier, so we should always try that first. So in this case, we want to find two numbers which multiply to be negative 4, add up to be positive 3, and those are going to be 4 and negative 1. Okay, so we have x squared minus 1x and plus 4x, that's a plus 3x. 4 times negative 1 is negative 4. So these numbers, they multiply to negative 4, they add up to be positive 3. So now by the zero product property, we're going to say that if this product equals to 0, then either x plus 4 must be 0 or x minus 1 must be 0. And that gives you x equals to negative 4 or x equals to positive 1. So there are two x-intercepts, negative 4 and positive 1. So the smaller x-intercept is x equals to negative 4, and the larger x-intercept is x equals to positive 1. So here I would put negative 4, and here I would put positive 1. And then the problem doesn't ask for this, but the actual ordered pair is negative 4, 0, and 1, 0. Because it's the x-intercept, the y value must be 0. Okay, now for the second part, let's find the y-intercept. For the y-intercept, we need to set the x value equal to 0 and solve for y. So let's go ahead and set the x value equal to 0. So we're basically trying to figure out what is f of 0. Remember, the x value is the input, and so we're going to replace the parentheses with the input. So we have f of 0 that equals to negative 0 squared minus 3 times 0 plus 4. Now anything times 0, or 0 squared is 0, so that's going to give you 0. 3 times 0 is 0 plus 4, and then this gives you 4. So f of 0 equals to 4, meaning when the x value is equal to 0, the y value is equal to 4. So the y-intercept is going to be y equals 4, and the ordered pair, which they don't ask you for it, but the ordered pair is 0, 4. All right, now lastly, let's find the vertex. So let's start with the original function, which is, and you always have to use the original function. The only time you can divide by negative 1 is when we set this equal to 0 and make this into an equation. But when we have the original function, we need to keep that the way it is, unless we set it equal to 0 and solve. So in this case, we need to use the vertex formula, which says that in order to find the vertex of a quadratic, the x value is given by negative b over 2a. So our a value is negative 1, our b value is negative 3, and our c value is positive 4, which we don't need. But negative b, that's going to be negative 3. b is negative 3, so we have negative 3. Over 2 times a, and that's going to be 2 times negative 1. So negative 3, this becomes a positive 3, and 2 times negative 1, that's a negative 2. And if you divide 3 by negative 2, this gives you a negative 1.5. So the x-coordinate of the vertex is negative 1.5. Now we're not quite done yet, because remember that we still need to find the y-coordinate. So in order to find the y-coordinate, we simply need to plug in x equals to negative 1.5. So we're basically trying to figure out what is f of negative 1.5. So that gives us negative parentheses negative 1.5. You know what? Let me actually rewrite this. It's a little bit smaller. I'm running out of space here. Okay, so I have f of negative 1.5. So x equals negative 1.5. So I replace the input with negative 1.5. That equals to negative parentheses negative 1.5 squared minus 3 times negative 1.5 plus 4. Now, all you need to do is you need to plug this into a calculator. Make sure you do it carefully when you plug this in. So if you're using a non-scientific calculator, follow the order of operations, exponent, and then multiply, etc., etc. But if you have a scientific calculator, you can just plug this in exactly the way it looks. But I'm going to show you guys a way, in case you do it step by step. So first you would do the exponent, which is negative 1.5 squared. That gives you 2.25. There's still a negative sign in the front, so that gives you negative 2.25. The two negatives don't multiply to be a positive because we need to do the exponent before we can do multiplication. So that gives you negative 2.25. Then we have negative 3 times negative 1.5. That gives you a positive 4.5. And then we have a plus 4. Okay, going left to right, we have negative 2.25 plus 4.5 plus 4, and that gives you 6.25 as the y-coordinate. So we have f of negative 1.5 equals to 6.25. So we got the vertex using negative b over 2a, that was negative 1.5, plug it in to get the y value. So the vertex is the point negative 1.5 comma 6.25.